Well, welcome back to another session of Math 103. We're going to start today by taking a look at the crazy homework assignment I gave you to do last night, dealing with the Wegmans water bottle problem, and also the problem about folding paper, which is on the back of that sheet. So if you would get that sheet out and make sure it's handy so that you can take a look at what you did on it. Hopefully you've sent me what you did on it so I can give you credit for having tried it. And then today, now we will correct it, of course. You can reprint it if you want to redo it the different way or something, but don't worry too much about that. So I would just like to say also that I am probably not going to switch to the calculator every time on this problem. So if you can get your calculator and have it handy for when we're doing this assignment and we set up the various steps of dimensional analysis, you will be able to use your calculator to perform the steps right along in case you weren't able to do it when you originally did the problem. So let's go with that, okay? All right, now what I've done is I've taken this huge problem and I've split it into smaller segments so I can show work under it. If you recall, we're dealing with water bottle packages that are 35 packs of water bottles that are wrapped in plastic, and I found that they weigh 41 pounds and they're 7.5 inches tall. Using that information, we are going to take a look at the various problems I proposed here and see what we can do with them. All right, so it said in the first one, how many cases, 35 packs, would need to be stacked on top of each other in order to reach the height of a 6-foot 3-inch female high school basketball player. Well, we have to know how many of these stacks are going to go on top of each other to equal 6 feet 3 inches. Well, I think most of you are very aware that a person who is 6 feet tall is 72 inches tall. And if we add the additional 3 inches of her height on there, that would mean that our basketball player is 75 inches tall. So let's go with that. And we're going to convert 75 inches, all right? So we're going to start with 75 inches over 1. And we're going to convert that to how many water bottles tall she would be if you stack the water bottles, or were able to stack the water bottles on top of each other. Of course, you could stack the cases on top of each other, but so let's just use one water bottle. Well, one water bottle is 7.5 inches tall. So if I want to go from inches to water bottles, all I need to do is put my 7.5 inches down here, all right, and one water bottle up there. Now I think you can see inches would cancel, those would be gone. My answer would be in water bottles, all right, and we can get the answer in water bottles by simply dividing 75 by 7.5. So if you took your calculator last night and took 75 and divided it by 7.5, you'll find that you would have a height of 10 cases. If you stack 10 cases on top of each other, they would equal her height, okay? Fairly simple, straightforward problem, right? Using dimensional analysis, we know exactly what to do to get the answers we're looking for, or the answer we're looking for. All right, let's go on. Which would weigh more, the female basketball player or 35 cases equal to her, or the cases of 35 packs that equal her height? Well, we really don't know how much she weighs, right? But we do know that each case of water bottles weighs approximately 41 pounds, all right? So we know if we have 10 cases, and we want to put that into pounds, all right? There are 41 pounds per every one case, right? since those two numbers are on top, I know I will just multiply them together. And you can almost do that in your head, right? 410 pounds. By the way, this symbol right here, the number symbol, also often represents the symbol for pounds. I hope I'm not confusing anybody by using that symbol. Now, with this answer in mind, 410 pounds, I pray to God that this girl is not heavier than 410 pounds, particularly if she's a basketball player. I very much doubt that she could weigh anywhere near 410 pounds. So we're going to assume, by just a logical thought process, that the cases that we've stacked on top of each other, the 10 cases, obviously are going to weigh more than she would. Okay? Now let's go on. If the HSBC tower, which is renamed now, but if that tower is 846.4 cases tall, what's the height of the HSBC tower in feet? Well, let's see. If I take 846.4 cases, all right, stick it over 1. Each case, remember, is 7.5 inches tall, right? So I could convert the cases to a height in inches by simply putting one case down here, right? And putting what? 7.5 inches up there. Well, the cases would cancel. But I'm not going to compute this right now. I'm going to get the rest of the information down I need to complete what they're looking for. We want to know how many feet tall this building is, okay? So there are 12 inches in every foot, right? So if I put my 12 inches down here, my 1 foot up here, okay, inches will cancel. So this should give me the answer I'm looking for to the height of this building in feet. Okay, now let's take a look at how we get that answer. Wouldn't we do 846.4 times 7.5? And then we would divide that answer by what? We divide that answer by 12. So let's try it. Okay, let's try it. So we'll do 8. Oh, let me clear this first. Sorry. All right. Where's my clear button here? Can't even find the clear button today. All right, 846.4. I'm going to multiply that times 7.5. All right, going to get that answer. And now I'm going to take that and divide it by 12. Okay. And when I do, I get 529 feet. I don't know about you, but I go to hockey games all the time to watch the Sabres play, and I look at that building, and it sure looks one heck of a lot taller than 529 feet. But this is what Wikipedia says, so I'm not going to argue with it, all right? And we're going to assume if you have been down there downtown near the waterfront and you've seen this very tall building, you notice that there is a very large slope that runs underneath the building. So on the back side of the building towards the Buffalo River and towards Lake Erie, you would find that it's probably taller if you measure from that point up to the top. But on the uptown side of the building, it could very easily be 529 feet. Well, we're going to go with what we have here for an answer. So we won't worry too much. All right, now, the next part says, how many folds of a single sheet of paper, if you could get a huge piece of paper and fold it enough times, are required to surpass the height of this building if you put this stack of paper or you put this folded paper on the uptown side of the HSBC building? Well, unfortunately, I did this in feet, right? And of course, But what I want to do is change 529 feet into how many folds are required to get or how many sheets of paper are required, so that I can figure out what the folds would be that equal this height in feet. Well, I really wanted it in inches, right? So I'm going to take 529 feet and take it back to inches. There are 12 inches in every, obviously, 1 foot. Okay. All right. Now, what is the equivalent we use for sheets of paper of thickness? How many sheets of paper of thickness do we need for every inch? Well, if you recall, it's 250 sheets per inch. So I'm going to put 250 sheets on top. Why did I decide to put it on top? Because I want inches to go away. So inches has to go away to cancel with the 12 inches. Feet have canceled out. So if I do this, I will know how many sheets of paper stacked on top of each other would be necessary to reach the height of 529 feet. So on my calculator over here, I'm going to take 529, multiply it by 12, just like it says to do in the dimensional analysis setup, get that answer, and divide that by, or excuse me, I don't want to divide it by that. I'm going to multiply that times 250. And I get 1,587,000 sheets of paper. It's a lot of paper. Okay? Now, I want to know how many times would I have to fold a piece of paper to either get that or beat it. Just beat it. Now, remember, we got to do this by trial and error. We're not going to do a logarithmic equation. So 2, the folds, every time you fold a sheet of paper, you double it. So we're looking for what power of 2 is either equal to or just greater than, all right, 1,587,000 sheets of paper. So take your calculator now. I want everybody to do this. Would you please do 2 to the 15th power on your machine? So that would be 2 caret 15. When you do that, I got 32,768. Well, that certainly isn't large enough, right? So 2 to the 15th is 32,768 sheets of thickness. Not big enough. We got to go a lot bigger than that. All right. Well, let's try 2 to the 17th and see what we get. So if we do 2 to the 17th power, okay, let's see. So let me clear this. 2 caret 17, enter. I get 131,072 sheets of thickness. We're still not there yet, right? Well, let's try 2 to the 20th. All right. If we do 2 to the 20th power, it would be 2 caret 20, enter. Ooh, 1,048,576. 48,576. Well, guess what? I'm really close there, right? 20 folds would almost do it, but really I'd have to go to what? 21 folds. And of course, when you do 2 to the 21st power, you're going to see it's too large. It's going to be like 2 million sheets of paper thick. So, but we'd have to fold our piece of paper 21 times. And after we had done that, due to exponential growth, we would find, okay, 2 caret 21 equals 2,097,152 sheets of thickness. Therefore, 21 folds would do the job. 20 folds, we wouldn't make it. We'd be short, okay? So we would have to do 21 folds of the piece of paper to at least equal or just surpass the height of the HSBC tower downtown. Wow, that's quite a few folds. Amazing, huh? All right, let's go on. All right, which pickup truck bed contains more weight? One that contains 32 cases of the 35 packs of water bottles, or a bed of a pickup truck, exactly the same pickup truck, which contains 82 16-pound bowling balls? Well, let's see. How much will 32 cases of the water bottles weigh? Well, if I start out with 32 cases, stick it over 1, and if I take that and I convert it to pounds, for each one case, why did I put one case on the bottom? Because we want cases to cancel. It's 41 pounds. So if you multiply 32 times 41, we should have the answer, right? So I'll take 32 times 41, and the answer I obtain is 1,312 pounds. That's how much 32 cases of those water bottles would weigh in the back of that truck that we put in the back of that truck. All right, how about if we put 82 16-pound bowling balls in there in a pickup truck bed? What's the story? What's that weight? Well, if I have 82 BBs, bowling balls, we know each bowling ball weighs 16 pounds. I put the 16 pounds on top because the bowling ball has to cancel on the bottom. And if I multiply this out, I should have that weight. So I'm assuming you probably did this last night. 82 times 16. And notice a little bit of a coincidence here, right? They both weigh exactly 1,312 pounds. Now, the chances are that the water bottles might not weigh exactly 1,312 pounds because the cases might vary in weight just a little bit. But assuming they're all 41 pounds, the weights would be exactly the same. So there is a quick summary of what you had to do to solve the water bottle problem. Now, let's go on and let's take a look at the Billy folding problem that's on the back. So remember, he can fold a huge piece of paper on the average every 30 seconds. The reason I said that, as he gets into the number higher folds, it's much harder to fold that thickness. So that's why I made it an average of 30 seconds. So he's been promised to be paid $5 per inch layer he has of sheets of paper formed on those folds, okay? And will he earn more than $1,000 if he's able to pull this stunt off, okay? And remember, there are 250 sheets per every inch. Let's see, if he's folding every 30 seconds and he's working 8 minutes, all right? How many folds will he have made during this period of time? Well, 8 minutes has, each of the 8 minutes has two 30-second periods in them. So that would be 16 folds, wouldn't it? That would be 16 folds. So how many layers of paper of thickness is he going to have, all right, if he folds the piece of paper 16 times? Well, as you recall, the power over the 2 is the number of folds, and 2 is the base that you place under that power. So I'm going to do 2 to the 16th power. That is going to be my number of pieces of paper thickness I have. All right? I'm not going to worry about working that out. I'll work it out as I do the problem. Now, what am I going to do next? For each of those sheets of paper, for each of the inches of height that are gained by these folds, there has to be what? 250 sheets of thickness per every 1 inch. right? So where does the 250 sheets go, and where does the 1 inch go? Well, 2 to the 16th power is the number of sheets, right, of layers of thickness that he would get by folding 16 times. So the sheets have to go on the bottom, all right? So, all right, you understand that? So there are 250 sheets per every 1 inch of height he would have in that folded stack. All right, but wait a minute now. It says 8 minutes. Let me see. I see $1,000 stunt for his friends. Okay, he's going to get paid $5 per inch. Okay, so what am I going to do to get this into money? Well, the answer I would get now would be in inches, right? For each inch he has, he's going to get paid $5, right? So I want inches to go away. So for every 1 inch, inches will cancel, he's going to get paid $5. So you see, this dimensional analysis very nicely lays the problem out for how we have to do it. So you can see we're going to have to do 2 to the 16th, multiply it by 5, and then take that answer and divide it by 250. All right, so if you had trouble with that last night, do it right now. We'll do 2 caret 16. We get this massive number. I hit enter, all right? And then I multiply it times 5, and I get that answer. And then I take that answer and I divide it by 250. And when I do, okay, I get $1,310.72. So, will he be paid more than $1,000 for this stunt? Yes, he will. And if I had given you this problem on the math test I hope to give you at the end of this week, you would have to show me the 1310.72, how you got that, and then you would have to write a conclusion, okay? Yes, as it shows, he would make greater than $1,000. Often, mathematicians like to use this saying to say they've done enough to prove something. It's called QED. Now, QED has a Latin meaning, but it kind of means quite enough done. So if you write QED after this, after your explanation and the work you've shown, you're like telling me, hey, pal, I finished this problem. I've done quite enough to show you what the correct answer would be here and that I am right. So if you want to write QED after it and an exclamation point, I don't have a problem with that. Give me a little attitude, but I like a little attitude. That's good. So, all right. So now we have taken the time to go over the homework very carefully. I hope you found this to be helpful. Okay? I hope you found it to be very helpful. All right. Now, we're going to go in to another section of the course right now where we deal with sequences of numbers. All right? And to show you the sequences of the numbers, okay, we're going to have the other professor who wrote the book show you some information about stuff in nature, all right? So we're going to take a look at a video. So I'm going to stop my video, and we're going to have a couple of short video clips that are going to occur, one for the author, then me, then the author, then me, then the author, and then I'm going to a longer explanation. So that is about to take place now. So I'm going to sign off for a moment, and please watch this professor explain some things that he has found in nature, okay?